that you have to understand timber in its own way.
Who do you think is more on the side of timber in architecture?
The right topology for wooden constructions. If you do the math, you could just calculate that.
Projects where you faced a challenge in regards to timber construction?
Change all the elements from concrete to wood.
Today we are visiting Eike Architecture, an award-winning architectural firm with expertise in timber construction, specializing in diverse urban projects, including public spaces, skyscrapers, interior and product design, designed to meet the evolving needs of modern cities. And I'm here today with Konrad Hoffmann, a Master of Architecture architect and project leader at Eike Architekten. Hi Konrad.
Hello Maria.
Thank you for your time and thank you for having us. I think we can dive right into the questions
yes,
that we
please.
prepared together.
Yes.
So the first question is a little broad, but I would just love to hear your opinion on this. What is the most important thing to keep in mind when building with timber?
We met at this exhibition, Woods Up, at the Aides Gallery, and it was a group exhibition, and through all the projects you could see that timber has been used in many different ways. We as a culture, we know timber furniture for a while, we know timber buildings for a while, especially in Germany. We as Eike architects, we use timber as mass timber. So we like to replace the concrete due to its obvious reasons with timber, mass timber construction. And we tried various ways to do it. So we have the cross-laminated timber, the pure solid wooden elements that we use. We like to use it in facade designs, as shown in the Rocky Wood project. We like to investigate. So what is most important, that you have to understand timber in its own way. So working with concrete on that end, you could just shape forms. The structural engineer would help you bend the steel and make it into that shape. With wooden elements, obviously you have to respect the grain of the wood, so direction. If you understand how wood behaves when it becomes in contact with moisture. All these fascinating elements of wood are aesthetically pleasing. We especially like the warmth that it gives to an environment. The acoustics is much different than in any other type of mineral-based construction materials. So we really appreciate that wood is available on an industrial level. So it gets sorted by grade. Once the companies produce a beam, it's grade A wood, pre-sorted, so that's one side of it, but there are also other companies that use the B type or the B class or the lower class quality of wood to construct other building elements that are maybe they're hidden on the back side of the house. So all these elements that the industry is ready to use mass timber on a broader scale in building construction is fascinating to me. And then what is important to know is how wood behaves in its pure form.
Thank you so much for the very insightful answer, and I think that actually leads perfectly into the next question that we got from our audience. What are actually the biggest advantages of timber constructions besides it being sustainable and being viewed as sustainable?
Sustainability is in the spotlight at this moment. So society is asking for what's the planet going to be in 10, 20, 30, 40 years? What if there wants to be a world we live in 100 years? And everyone knows that we as a society consume much more all of these elements than we actually should. When you think about wooden elements, the fact that sustainability could also mean the weight of a building. As Foster said, if you do the math, you could just calculate that a wooden wall compared to a concrete wall is just much lighter, which means the concrete foundations would be way less, which is also really attractive on a process scale. So if you understand the system, the lightweight in itself in the construction material and the engineered type of wood would lead to much lighter buildings. That's one aspect that I admire a lot, so that engineers are much more asked to come up with really ingenious ideas on how to solve a structural problem. As an architect, as I mentioned, I like the aesthetics, I like the flexibility, so I could use it as a surface material. I would still admire it just by the pure looks of it, or it's a different kinds of wood. Yeah, so overall, the wooden elements that get used in different parts of the building might be different from itself. It's really a design question. Where do you use wood and for what purpose?
Thank you. Is, in general, timber construction a topic that you often find being enforced by architects or more by the people that purchase the plans from the architects and the project leaders and stuff like that, who do you think is more on the side of timber in architecture?
We work in projects where the end user is not known to us. So three parties that are involved in our processes: the city itself, developer, and it's the architect. And in my view, these three will need to find a balance in all aspects of the design of a building when it comes to not only sustainability but also life cycle assessment, what the building gives towards the city as a gesture, so facade design. So I couldn't really say if the general public purchases a home is really fostering us to use wood. Currently, it's a really strong push by the EU, this EU taxonomy that asks a lot from new build constructions, because the banks wouldn't just lend the money anymore if it's just not sustainable anymore, if it's not environmentally, socially or governmentally organized and well fit. We had one client really that asked for wooden construction. And then the second one was we chose to submit a competition design made out of wood. So this was a win, a hotel project. It's been really fascinating that everyone responds really well to these topics. So there's not many that say, wood is difficult or is more expensive. Yes, it's true that you would need really skillful industry partners, or you would need to find the right partner that provides the wood. But we believe that there's no big no-no to use wood at all. So it's really a great chance. We as architects, we try to implement wooden construction design elements where we think they fit.
Great insight that you just gave us, because I don't think many of you guys, and maybe not many of us, actually knew that it's being pushed by EU like that, and that they actually made laws for it and push for more wood constructions. I think that's super interesting to know.
So the EU is really not asking for wood they're not setting the material as has to be wood, but they do it in a different way, right? So we all know it's all calculated based on the CO2 emissions. Yes. And it's compared to this standard. So, but by lowering the CO2 emissions and to raising the bar, which a new built project would need to achieve, that's exactly where it just goes into that direction.
So, in your opinion, is timber in general more fitting for corporate projects or for residential buildings? And if so, which one and why, maybe, in your opinion?
I think it applies really well to both these typologies or the use cases, right? So in residential projects, the challenge is to organize a home or an apartment within a bigger block, which can be solved quite efficiently with these wooden type elements that we know today. And in the corporate world, it's really fascinating because a building has this charisma of a wooden structure that brings it with it, right? So the credentials that align well with the corporate world in terms of social responsibility applies really well to wood as well. There's a good fit for wooden elements in both these use cases.
Very interesting that it's kind of for two different reasons for both of them, but equally important and maybe useful in both residential and corporate projects, as you said. How do you think how can you build with timber and make it economically sustainable for long-term projects? And how do you minimize additional costs that come together with building with timber?
Well, now we mentioned that if you have pre-sorted qualities in the wood, you are good. You're as good as concrete would be, right? And then you would prevent anything that could harm the wood. Once you have all these elements settled, right? So maybe you sort it in a different way. When it used to be a concrete wall and a layer of paint, now maybe you choose wood as a solid construction, then you add a layer of another wooden element, and you use foils, for example, to prevent the moisture from getting into these different layers in your system. So maybe that's the best answer I could give you. In terms of retrofitting, so there's one element in our design practice where we also try to not only find the best fit for the client and his use case for the first time the building is in use, but we also look at third parties that might move in the future, right? So we try to find the common goal of these use cases that could happen, right? For example, if we design a building structure, we know it's made for the working environment of, let's say, a room, 2 people work in there. We know we do everything we can to get the acoustics right. We look at work-related elements that we need to provide to these people that use the space. But we also try to think about the bigger picture. So what if this entire building structure would become something else in the future? What if it was to be used as a residential apartment unit? We could definitely, by the structure we chose, allow future architects to change that building into something else, into a different usage. Right?
That's incredibly smart, and I think that's the actual sustainable way to use wood and construct in general. I think that's really impressive. While we were talking about kind of the projects you made as a company and different buildings you have created, can you maybe share a story about one of the projects where you faced a challenge in regards to timber construction and maybe how you overcame it?
Sure, there are many moments when you start as a design architect and you look at different solutions that would fit your design idea. So for example, we had this one project in Frankfurt right next to a high-rise that we also built, and the one is much lower. It's called Timber Pioneer, and it uses wood. And it's been built, so it uses concrete as a base and it uses wood on the upper floors. But this project came to us way before Corona crisis happened, and the world before Corona was much different. So it was actually conceptualized as a hotel. Now, while Corona happened, no one actually thought it was a good idea to, build a new hotel at that specific location. So they changed the use case while we were in the design phase. A little bit later, already we were in the documentation phase, so design phase has passed. The building volume was set, and now we were in charge of converting this hotel idea to an office building. Now, the second challenge was that the client said, you change the use case, but also please change from concrete to wooden construction. Because these moments just make you think, right? So when there's a project being stopped for a particular reason, everyone just gets together and thinks about, are we doing the right thing? Is it a really good idea to build a hotel out of concrete? No, let's do office out of wood. But the project was also really set in a way that it was not quite easy to change all the elements from concrete to wood because of fire regulations, various reasons. That's why I would think this project Timber Pioneer is not a pure wooden project. It's a real hybrid. Right, so the base element, the ground floor, was still made out of concrete. Staircases on all these fire-relevant rooms were also made out of concrete still. And also the middle part of all the floors were made out of concrete because these vertical pipes, which need to have a certain way, they are just surrounded by non-burning materials, have been already designed. So the MEP planner was already done with this work, and we would just try to use the same concept. So that was really challenging, to change the concept from concrete to wooden elements while it was already on the fast track to being built.
Yeah. When you've actually already started building with the wood, so there's maybe you had a project where you already started building, did any issues come up there? So maybe something couldn't be executed or something happened with the wood? Because that's a question a lot of students have, that I found, that they're like, how do you even make such big constructions with wood? It seems like such a fragile material in a way, if you know what I mean. Having the whole construction skeleton sometimes even being built out of wood, everyone is just like, how do you plan that even? So
yeah, well, there actually in Germany there's norms for everything, and there's also a norm that just says how wood, if used as the load-bearing elements, need to be engineered. And for example, this fire element, they just look at a wood beam, for example, and they just test it. So how quickly this beam loses its stability when exposed to fire, for example. And since they just know it, the norm just tells you how to thicken this beam so that, for example, we would have, let's say, 90 minutes to leave the building so that the building remains a building even though it's on fire. And you just enlarge and thicken the beam so that these 90 minutes pass. Yes, the wood is being burned in these 90 minutes, but by a certain percentage. It just means you just engineer the structural element out of wood based on these properties that you need to find. So, for example, fire regulations. We tried one project that in the typology of a high-rise. Mm-hmm. We tried, it's in Offenbach. The project is called NAMU, and it was quite interesting that it was a high-rise 120 meters tall, and the regulation demanded that it needs to be F150. So the building needs to stand for 150 minutes in its way, but the raw material was wood. So we enlarged the wooden beam by just that thickness that would burn away in 150 minutes. It's incredibly interesting to find the right topology for wooden constructions. Because if you enlarge a beam not only in its width but also height, you overshoot, for example, the engineered height that a concrete beam would have, right? So if you would work with 30 centimeters of concrete slabs, you suddenly have 60 or 80 centimeters of wooden beams that you need to incorporate. Now, when you think about a high-rise topology, the height is really interesting, but you need also have these amount of floors in it. Meaning the height of this beam, 80 centimeters, kind of eats away from the effectiveness or this ratio of built volume to usable square. And then, interesting enough, also the facade material is 80 centimeters taller. And on the third part, you know that building office typologies use a lot of cooling energy. Yes. And this cooling energy is also obviously spread across the room, right? So if you have a bigger room volume, you'd need to have more cooling energy to make it fit. So these were really interesting moments when we just discovered, look, there's a perfect match for these typologies when made out of wood. And this is also based on these regulations and fire aspects.
So it's like building a puzzle. In a way, like you have to connect the regulations and then also making it sustainable, and everything is like, it has to work together to make the perfect project.
That's in my point, these three parties, right? Yes. The city, the developer, and the architects.
Wow. Yeah. That's such a great insight. Thank you so much.
You're welcome.
For your time and for the interesting information. We definitely learned a lot today. Yes, thank you.
Thanks for stopping by, Maria.
Thank you.
Yeah.
Okay, you can cut. Perfect.